Hi, so we're on part two of the general sine and cosine functions. And we saw this section is about the transformations. So let's write this here again. Y equals, this is the general sine function. Here we see this would affect the horizontal, which is again counterintuitive, 1 over b, and if it's minus, then it goes to the right. This is the vertical, and this would be again vertical, and that would be the amplitude. The b would be for the period, where it is 2 pi over b, and the d would be the vertical translation, and the c is the horizontal translation. That's the d, the c is the horizontal. So again, like I said in the previous video, our transformation in all functions can go either horizontally or vertically, and they both have stretches or just translations. Translations keep the same form, but they just change it, move it up or down or left and right. And the stretch it, either enlarging it or reduction. So this is good to follow. So we were starting to solve questions. Let's look at them. Okay, state the transformation which maps y equals sine x into, so here what we have here is a transformation. That would be vertical translation we see here. So if this is sine x, we have the same, just one unit down. This would be here, this is just let it down. So this is a vertical T translation. This would be a horizontal translation. If this is our sine, then the new one will go pi over 4 units to the right because it's minus. Again, as I said, this would be counterintuitive. Everything stays the same. It's hard to do that. Let's see. Something like that. This is, you see, it's outside. It's not within the sine, it's outside of the sine. So this would be a vertical, and it's a vertical stretch. So if this is our sine, then that would be this is inside of the sine. You see it's inside, so that would be a horizontal stretch. And of 1/4. Okay, so if this is our sine function, then that becomes, I'll have 4 periods here in this case here, okay? So it's really might be difficult to draw like this, but okay, so that would be, let's see, something like this. And we should have 4 of them over here. This is sine of x over 4, so it is very similar to that. It's inside the sine, and that is makes it not vertical, sorry, horizontal stretch. But this time with the scale factor of 4. So if this is our sine, then it will be not 1, 2, 3, 4. It will be something like that. And here we have both the vertical because of the +2 and horizontal of the -π/3 translations. This is the original, then this should go π/3 units to the right, and then up 3 units. So that would be actually where it is. Okay. The same for the transformation of cosine. I hope this really helped you. So transformations which maps y equals cosine x. So that is vertical, it's outside, and that is a stretch. This is a reflection on the x-axis. This would be translations both vertically and horizontally, like part F here. So let's continue with that. Take the period of, so here the period will be 1/5, 1/3, or if we want to state, it has to state the period, so we should use the period, let's just erase that, let's see, that's great. Okay. So the period is 2π over p over b, so that would be 2, here b equals 5. Okay, we see here this is the b, so that is 2π over b, or over 5. This is 2π over 0.6. 2π over pi, 2, and so on. Find b given that the function y equals sine b over x has period of 5π. So now we have the period given. We need to find what is b. So period equals 2π over b. So b equals 2π over period. Why is this helpful? Because sometimes we get the graph and we see that recurs after 5 pi. So from the graph, I know it's 2 pi over 5 pi. In this case, then I'm doing 2 pi over 5 pi, and b equals 2 over 5. Same for 12 pi. 2 pi over 12 pi. 1 over 6, that's the b in the function. So we have a function, an equation, and we have a graph, okay? The period can be taken from the graph, or unless it just says like in this question, and then we find the b to create the equation, or if we have the equation like in question number 3, we can graph it now because we know what is the period. And it can be 2 pi over 4 in this case. Then the b would be pi over 2. That's a b. State the maximum and minimum values of y. Okay, so we saw that the maximum and minimum value of cos and sine is always between -1 and 1. So this could be either for the maximum, it could be 1, cosine 2x would be 1, then it's 4, or -1, then it's -4. Cosine x could be +1 for the maximum or -1 for the minimum. So that is 3 over 5 for the maximum, or -3 over 5, -3 plus 5, which is 2. And you see the amplitude is 3. Okay, if I'm looking at this would be the principal axis is 5, and then amplitude of 3 will take me to the maximum of 8, and minimum of 3 will take me to the point of 2. Maximum minimum values, again, this could be cosine is maximum at 1, so that is -2 times 1 -4, which is -6, or minimum when it's -1, -2 times -1 is 2, -4, which is -2. So this is actually the maximum, and that would be the minimum. But the values of cosine and sine only range between -1 and 1, and this is where we get the maximum. Question number 6. This would be the amplitude. The period would be 2 pi over 3. Okay, using this formula, 2 pi over b. And the range, okay, the range would be, the range, okay, is the possible values for y. Okay, so this would be the principal axis is y equals 2. Now I know the amplitude is 4, so that would be y equals 6, or -4, which is y equals -2. So our range is y between -2 and 6. Okay. Sketch the graphs for the following. So you can sketch it. That is, if you have a better paper for that. Sine x is here, so sine x -2 would be here. Sine x plus 2. So I know sine x is 2 pi, the period, but here it's a horizontal translation to the left. So 2 pi is 6.28, so that would be 4.28. So it will look something like that. Now it's between 0 and 4 pi. So we have here another one up to here. And the same, everything would be moved to let's do this one right here. So the original looks like that. No, no. Okay, this is 2 pi and this is 4 pi. So x plus 4 is a horizontal translation to the left by pi over 4 units. Much better to do it accurately. And then adding 2, this is a vertical translation upwards. So every point will move to, it's actually much more than what we see here, because this is -1, so that would be up to even 1. Okay, I think it's already too long. Let's stop. Bye.